Hello class 10. Today we are going to start a new chapter of ICSE Physics class 10, that is work, energy and power, and we will discuss each and every topic under this in detail. Okay, so first of all, our first word is the work. Okay, dear student, in our daily life, in our day-to-day life, if someone is just reading a book, or he is cooking a food, or is moving, that a box is just over his head or a shoulder, he is moving, normally we say that the work is doing that particular person. Okay, means work is nothing but it is some sort of just mental or a physical activity that the common people think. Okay, but in subject physics, the work has entire different meaning. The work is totally entire different meaning in physics. That is, when we say that the work is said to be done, the work is said to be done when whatever the force we are going to apply on a body, it produces some displacement in it. That is, whenever a force is applied on a body, it produces some displacement. That is, the body have to move somewhere, or it will just displace from one position to another position. Only in that case we say that the work is said to be done. Otherwise, if we apply a lot of force and the displacement is zero, that there is no displacement, we can't say that the work is said to be done in that particular case. So what is the basic criteria? What is the basic criteria to say that the work has to be done? The first one is the amount of force applied on a body, and the second one is the just displacement should be produced in the body. It means it should just move from one position to another position. Okay, student. Suppose we can take a very common example, that suppose a wall is here only, and a man is just trying to push the wall and he's applying a lot of force on the wall. The wall doesn't move, displacement is zero, so work done will be zero. So in order to create work, the magnitude of force is also needed, and the displacement, the body should displaced from one position to another position, is also needed. These two factors just define the define the work. So in order to understand the work is totally depend upon the two important things. The first one is the magnitude of force applied, and the second one is the amount of just displacement produced in the body. Okay, so as a whole, we can say that work is equal to the amount of force applied on a body into displacement produced in the direction of the force. Means, as a whole, we can just keep in your mind two things: the magnitude of force applied, and the displacement should obviously produce in the body. Otherwise, work done will be zero. So sometimes one thing you have to keep in your mind, that the direction of the displacement should be in the direction of the force. Direction of the displacement should be in the direction of the force. That is, in order to get the maximum work, the direction should be same. That is, direction of the displacement should be in the direction of the force. Only in that case we will get the maximum force. Okay, so sometimes it is not necessary that the force, whatever the force is applied on a body, it is always in the same direction. Always the direction of the displacement should not always be in the direction of the force. So that in this case, in order to find out the maximum work, the two cases arises here. The first one is this one, that is, we have to find out in that case whatever the force is applied on this particular block, in this particular body, it should be displaced like this in the straight line, but it is displacing like this, means it is creating and it is displacing, the body is displacing from this position to this position by an angle theta with the horizontal. So in this case, obviously we have to find out the work as whatever the force is applied, the displacement should be in the direction of the force. So we have to apply the work in this direction, means force into AB. So in this case we have to find out the component, okay, the component of displacement in the direction of force. How we will able to find out the component of displacement in the direction of force? Although the displacement is in a different direction, it is having a direction along inclined at an angle theta with the horizontal. So we have what here, how we will able to find out the work? Here we can find out the work is equal to force, direction will be this only because I am applying a force in this direction. So force into AB in the direction of force, means AB is in the direction of force. So we will find the component of S in terms of AB. So F equal to AB. Okay. So in this case we have to find out the AB. How we will able to find out the AB? From this right angle triangle. Okay, this is a horizontal line, this is perpendicular I have drawn here from the just final position. So we know that in any right angle triangles, this is a right angle triangle and this is, suppose this is 90 degree, and we know that the side opposite to the 90 degree is always hypotenuse. So this is hypotenuse, this side is hypotenuse, and we also know that the angle theta, the side opposite to angle theta is always perpendicular line. Always perpendicular means 90 degree, this is perpendicular line, and the left one is the always base. So with applying all these thing, we will able to find out the AB in terms of S. So in right angle triangle ABC, in class 10 mathematics we will also study this, that how we will find the cos theta. I am just going to find out the cos theta. Cos theta is equal to what? This is base and this is hypotenuse, I have just discussed now. This is base, so AB by AC means cos theta is always base upon hypotenuse. This is base, so AB by AC. Or what is the magnitude of AC? This is displacement, just substitute it. Or AB is equal to S into cos theta. This is okay, we have just find out this AB in terms of just S. So what is the total work here? So work will be equal to force into AB. Okay, so F into S cos theta. This is the amount of magnitude of work, okay, in terms of displacement, in the component of displacement in the direction of force. This is one case, okay, when we have find out the component of displacement in the direction of force. Here in this case we will find out the just component of force in the direction of displacement. Here is a component of displacement in the direction of force, and here we have to find out the force I am applying. This one is a force in this direction, and we have to find out the component of force in this direction. So we have to create such a situation that in the direction of displacement force will also act. How we will create a situation, we will draw it, the line backwards, okay, draw it backwards. This is amount of magnitude of force. We will apply it a perpendicular on this line, and this is 90 degree, okay, and suppose this angle is theta. This angle is inclined at theta. This angle will also be theta. Why? Because if two lines are intersecting in geometrical concepts, we already know that whenever two lines are intersecting at a point, at some particular point, then the vertically opposite angles are always equal. So in this case we will just able to find out. So vertically opposite angles will be always equal in nature, and this is 90 degree, this angle is 90 degree. So we already just discussed in this case that the side opposite to the just 90 degree is always hypotenuse, and the angle theta, the side opposite to angle theta is always this is perpendicular, this is hypotenuse, and left one is a base. So this will be base and this will be just hypotenuse. Okay, so we are considering here, suppose this is P and this is N, suppose. Okay, this is P, this is P, this is N. So what will be the magnitude here? We are just considering here component of force. This should be this force component should be in this direction, so the component this will be the component of force. We will find out. So the force and the S should be in this direction, so we will find PA. Okay, so what will be the work? The total work is PA into, this is PA into AC, means component of force into AC. AC is a displacement. So in this case, in right angle triangle, suppose this is right angle triangle, this is base and this is hypotenuse. So we will find out in right angle triangle, PAN cos theta will be equal to base by hypotenuse, means AB by AN. Base, this is base, this is hypotenuse, so AP upon AN. AN is what AN is just force, this is force, so cos theta will be AP upon just force. And what will be AP? AP will be F cos theta. So with this condition we will find out the work here. So I am writing here also, the work is what? Work is PA into AC. PA is F cos theta and AC is what? Just displacement here. So in this case work will be equal to just F cos theta into S, or we can say that just work equal to Fs cos theta, we can write here. Okay, this thing is the amount of work done. So dear student, we have just discussed here the component of displacement in the direction of force, and this is what the component of force in the direction of displacement. Okay, these two conditions of the work. So just go through and just clear the concept. We will meet in the next video. Thank you.